The third method is called elimination by addition. So that means from the name of this method, we know that if we add two equations up, then some variable will disappear. We can eliminate some variables. Now let's look at this example. Okay, let's look at this example. So if this is the equation 1 and this is the equation 2, if we notice that if we add equation 1 and 2, then you will see that the y terms will disappear, right? So when you add two equations up, that means you need to add the left side by the left side and the right side by the right side. So now let's look at if we have equation 1 plus equation 2, what does this mean? This is the 3x plus y equals 18 and plus 5x minus y equals 6. So we add these two equations up. So we right side of the equal sign add together, so this would be the 24 equals the left side, so x term plus x term, so it's 3x plus 5x would be 8x, right? And y plus negative y, which is 0. So this is 0. So you see we get an equation and there is no y anymore. Then we can solve this equation in one variable quickly, right? So we have 8x equals 24, so divide by 8, so x equals 3. So we have x equals 3, so you can plug in x equals 3 into any equation you have to get the y value. So for example, we plug in x equals 3, x equals 3 into the equation 1, okay? So you will have 3x plus y equals 18. So it's 3 times 3 plus y equals 18, right? Equals 18. So then you have 9 plus y equals 18 and y equals 9. So x equals 3, y equals 9, or you have the form x equals 3, y equals 9 is the solution of this linear system. Okay? So sometimes you can get this one quickly, but just by adding this directly. But sometimes you need to change a little bit. So now let's look at the next example. This is x minus 5y equals 35 and 5x minus 4y equals 28. Okay, so if this is the equation 1 and this is the equation 2, so we notice that if we add these two equations up directly, you will see both you will get a new equation which still contains x and y. This is not the equation we want. We want to eliminate one. So what we should do? Let's do the observations of the coefficient. So here is the coefficient of x equals 1. Here is 5. So if we can multiply the equation 1 by negative 5 on both sides, it will not change anything, right? Then you add together, you will see the x term will disappear, right? So now let's multiply the equation 1 by negative 5 on both sides. So they will have negative 5 times each term, okay? Negative 5 times x would be negative 5x. Minus 5y times negative 5 would be plus, right? 25y equals 35 times 5 equals 175, right? Then if we set this equation, this new equation is called equation 3. So you see, we multiply this number on both sides, it will not change anything, right? So we add these two equations. So 2 add 3. You will have 5x minus 4y equals 28. This is equation 2. And negative 5y plus 25y, x plus 25y equals 175. If you add these together, add them up. So you will see 5x plus negative 5x would be 0. This would be 19y, right? Negative 4 plus 25, 21. Y equals 28 plus 175 equals 3, 0, and 2, right? So y is equal to 203 divided by 21. Sorry, I made a mistake here. So here is, so we multiply by negative 5, so this would be negative 175. So if you add together, it would be negative 1, 4, 7, right? 147, negative 147. So this is the negative 147. Negative 147. So negative 147 divided by 21, which is equal to negative 7. So y equals negative 7. Then we plug in one of the equations we have. Which one is easier to plug in? It looks when we can just plug in equation 1, right? So we plug y equals negative 7 into equation 1. Then you will have x minus 5 times negative 7 equals 35. So x plus 35 equals 35, so x equals 0. So in other words, 0, negative 7, or x equals 0, y equals negative 7 is the solution. If you don't believe it, you just plug in to these two equations to see if 1 and 2 are satisfied at the same time. Okay, so this is the one example. Now let's look at a more complicated one. Next example. 3x minus 5y equals negative 7. Negative 7x plus 3y equals 25. So this is equation 1 and this is equation 2. So you see that from this equation, it's more like the first one. The first one and the previous one, not previous one. The previous one, we just multiply one equation by a constant, then add the other equation. You can eliminate the variables, right? But here, you cannot do that. You cannot multiply one number on one equation, then add to the second equation to eliminate the one variable. Okay, the reason is here you have the coefficient 1 and 5, so you just need to multiply a negative 5, then you can see the elimination. But here you have 3 and a negative 7, or negative 5 and 3, right? So here is the one thing I want to say, that we can multiply both equations with different numbers. Then you can see that one if you add them together, you can eliminate one variables. Okay. So here is the idea. If we want to eliminate a variable y, okay, not x. Of course, you can eliminate variable x, but here I want to try to eliminate the variable y to see what happens. So you can see this is 5, -5, right? And this is 3. So if we multiply the first equation by 3 and multiply the second equation by 5, then you will see that would be -15y and here is +15y. If you add these two equations up, you will eliminate the variable y, right? So let's see what happened. So we multiplied equation 1 by 3 on both sides. Then you will have three, so it's 9x minus 15y equals -21. Right? Then we multiplied equation 2 by 5 on both sides. So this would be -35x plus 15y equals times 5 on 25. So this would be 125. If this is the equation 3 and this is the equation 4, if we add 3 and 4, so you add them up, you will see this at 9x plus 35x would be -26x, right? And the -15y and the +15y, so you add together would be 0. And this would be 1 or 4, right? So you solve this one, you divide it by -26, so x equals 104 divided by -26. So this would be -4 if you use a calculator. So if we have x equals -4, then we can just plug in any equations you want to get y. So here we plug in the first equation. So we plug x equals -4 into the first equation. Then you will have 3 times -4 plus minus 5 times y equals -7, right? So this would be -12 minus 5y equals -7. So we add 12 on both sides, so it's -5y equals 5. So y equals -1. So we have the conclusion that -4, -1, or x equals -4, y equals -1 is the solution. Okay. Okay, so these are the examples of these three methods. The next, I want to look at the applications. So before that, I want to see some definitions or terminologies. Okay, so we see a system of linear equation is consistent if the system has solutions. Maybe one solution, maybe infinitely many solutions. Then we say the system is consistent. We see a system of linear equation is inconsistent if the system has no solution. Okay.